Okay. Finished breakout room number 2. Hopefully you did the activity for breakout room number 3, and now we can go over the answers. All right, identify A, B, and C as indicated by the arrows. So what do I have? I have a lot of fibers. So we're probably in the dermis, big fibers, maybe reticular layer. I've got glands. So these are little lumens, little cuboidal cells. These look like eccrine sweat glands, secretory portion, the dark duct portions here, the little fuzzy. Over here, I have a big fluffy gland, and I can see products in these cells, so they're making something, and they're big fluffy cloud-like. I'm going to go with sebaceous gland for this thing. Definitely looks different than the eccrine, and to me, and this is going to look like part of the epidermis. Maybe it's a hair follicle. So the hair is just falling out. It's obliquely cut. It looks like this is mainly showing you, here's the glassy membrane here, external root sheath, internal root sheath here, and then you kind of lose the hair. But, so that's what I'm looking at, hair follicle here. So I'm going to go with A is sebaceous gland, this one. B is eccrine and hair follicle. I'm going to go with C for this one. Great. Okay, clinical correlation is acne. So talking about sebaceous glands, you can get sebum stuck in the hair follicles. And you produce sebum differently in different parts of your body, different places of your body. You can get sebum stuck in hair follicles all over your body. You can get acne anywhere. You can get it stuck and it doesn't cause an infection. I think we commonly refer to that more like a blackhead. But you can get a sebum stuck, and then you can get bacteria that can infiltrate. It gets actually infiltrates more if you press on it. Can force bacteria down into a hair follicle and cause an infection. And that's how you get your body try to announce a response. You get white neutrophils as they show up in that clogged pore, and so it causes inflammation and red and all of the symptoms of acne. So this next question, what do you think the cell type that is highlighted? So I drew around the cell a pretend border here. You can see nuclei. So I would look at it and I would say, does it look like the other cells, or does this cell look different? Where am I? So I'm in the epidermis. Ooh, look at these purple dots. I'm thinking this is a stratum granulosum here. And these look like the stratum basale here, smaller, darker cells. Now they're making keratin. So I'm in the stratum spinosum. This cell looks pretty much like the other cells. So I'm just going to go with a keratinocyte for this one. All right, great. All right, next question. Identify the structure indicated by the arrows. Round, cuboidal shape, lumen. We got a gland here. The lumen size is pretty small. Here's a duct. So these are eccrine glands, and these are the secretory portions. The ducts are much darker staining in the ducts, so you can see, I like this, a great example because they're stratified. You can see 2 cuboidal cells in the duct. These are messy, but they're really, and they have dark cells and clear cells. I'll have to look at the lab to see whether you actually have to do that. You can even see myoepithelial cells here around the secretory portion. So this is actually a nice picture of an eccrine sweat gland secretory portion and the duct. And here you can see collagen fibers, little capillaries, every once in a while some blood vessels, fibroblasts in the connective tissue. So the cells that are making these fibers are fibroblasts. All right, great. Awesome. Actually, I'm glad we're doing this so I can play the video and show you sweat glands actually working. I just love this video, and you can see sweat coming out of the ducts onto the surface of the epidermis. Anatomy is awesome, isn't it? All right. So identify the region A and B. A, wow, this looks like the epidermis. So here you see the darker staining basal region. Stratum spinosum is going to be more superficial. And we have patches of dermal papilla sticking up in other regions. Excuse me. And then B, we have that depicted way down here. So let me see. Papillary dermis is going to be up here for sure. And then I'm going to look for transition of fibers. So it does look like this light pink becomes a darker pink and more concentrated down here. So I think B is in the reticular dermis, and that's what I'm going to go with. So let's see. Stratum spinosum, reticular dermis. Yay. All right. Identify the structure indicated by the arrow. Ooh, here's a low power view. Here's a closer up view. This is a beautiful cut onion shape. You can see where the axon is and the sensory receptor. This is the Paxtinian corpuscle, and a lot of them are down in the hypodermis, and this is a fingertip section. So Paxtinian corpuscle, vibration and deep touch. All right, A, B, and C. A, woo. So these are big cells, puffy, all close together next to a hair follicle. So I'm going to go with sebaceous gland for A. Here's a hair cut, so that yellow orangish cornified cut of hair always gives that away for me. Here's more hairs. And so for C, I'm going to go with these are hair follicles. And then for B, these have a pretty darn big lumen. These are not eccrine sweat glands, but here you can see eccrine sweat glands. So I'm going to go with apocrine glands for B. So let's see, that's sebaceous apocrine hair follicle. B would be what I would put. Fantastic. And this is a trichrome stain, that's why the collagen looks blue. Identify the cell type indicated by the arrow. All right. So I'm in the stratum basale. Here's connective tissue, and it's meeting with an epithelium tissue, and here's keratinized squamous cells. So here we have the epidermis. It also is the skin, but you know, if I can throw in other things. So this is a basal cell, right? It looks like a round cell. Cytoplasm is not pale like this one though. So it looks like kind of all these cells. Oh, I think this is just a basal cell. And that's what it is. So here you can see a melanocyte with the pale staining cytoplasm. Here's another melanocyte, here's a melanocyte. All right, identify the structure indicated by the arrow. All right, well here I see the epidermis, basal layer, stratum spinosum, and it's meeting the dermis. It's just sticking up here, and I don't see any sensory receptors. It doesn't look like a Meissner's corpuscle to me, so I'm just gonna go with dermal papilla for this one. Great. All right, identify the cell type indicated by this arrow. Really the question should be identify the structure, because this is not a cell type, this is a sensory receptor. So here I can see the epidermis, here's the basal layer, this is stratum spinosum right here, and this is a granulosum, a little kind of picture of the granulosum with the purple dots. So this is the papillary dermis here, nice capillary there. And this looks like an organized structure. It's a corpuscle. This is the Meissner's. This is where Meissner's end up being. And so I'm going to go with Meissner corpuscle. All right. Advanced. Think of a place this slide was taken from. So if you've done the 4 tissue types, I'm not 100% sure what your familiarity is at this point with muscle. And what I was trying to show you is a low power view. Here you can see this epithelium. When you look at it closely, there are no nuclei in the most superficial layers, and it's stratified and they're squamous shaped. So this is a skin, thin skin essentially. And then this looks not super clear. I don't know. We're gonna skip over that. Let's look at what the other box is. So if you zoom in this box, this is actually skeletal muscle. So the nuclei are all arranged on the periphery of the cells. So this is what skeletal muscle looks like if it's cut in cross-section. So I have skin directly over patches of skeletal muscle. And usually we have hypodermis, subcutaneous tissue that's underneath skin that causes a big separation. But in certain places of the body, you do have skeletal muscle that is very superficial without a fascia over the top of it. So let's see what our choices are. We've got the auricle. So if it was the ear, it could be the ear, but do you have a skeletal muscle just underneath the skin? I don't really think of that when I think of my ear. I think of cartilage underneath, so I don't see any cartilage in here. The scrotum, well, there is muscle underneath the skin in the scrotum, but that would be smooth muscle. It's autonomically innervated to help contract the scrotal sac when it's cold outside. The glans penis, let's see, so would it have thin skin? Yes, it would have thin skin, but would there be muscle directly underneath? No, not so much. There would be cavernous tissue. There wouldn't be a bunch of skeletal muscle underneath. There's no There's no bones or muscle in the penis. The lip. So I have thin skin, and then underneath, would I have muscle? Yes, actually, I would have muscles of facial expression, which are very superficial. So I like the selection of the lip for this. And the last one is the back. The back does have extremely thick dermis. It's one of the places on the body that has the thickest dermis. And this doesn't look very thick. And there would be a hypodermis in the back. So I'm going to cross that one out as well. So that for all of those reasons, and this is an advanced question that I wouldn't expect you to know the answer to. This is part of the learning. I'm going to go with the lip for this one. Woohoo! All right. Identify the region indicated by the blue arrow. So, I'm looking at all these cells packed in here, and then there's something in the middle, and there's another side, and then it looks like connective tissue. So, of all the structures we've talked about, it doesn't look like a gland because they're not cuboidal. This is very much stratified. Stratum corneum, I mean, it looks cornified, but it's not on the surface of anything. It's in the middle of something. Sebaceous gland, it's not a gland. These cells do not look like they're secreting anything. Is it a hair? Very well could be a hair. We could have the internal root sheath here, internal root sheath. We could have external root sheath here. I think it's going to be a hair. These Paxinian corpuscle stratum, but I'm going to rule out the other options. So we're going to go with hair for this one. Which of the two slides below, or one of the two, is basal cell carcinoma? Which one do you think represents this type of cancer? So the slide number 1 has a bunch of cells growing out of control that is adjacent to the epidermis at the basal layer. This one's looking pretty good. But then I have this one, lots of cells out of control. It looks very messy. It's very hard to necessarily tell any organizational pattern. Let's just pretend here that this looks like the surface and the stratum corneum. But these big patches, they don't have nuclei in them. These are actually big patches of keratin that is kind of filling up this section. So I actually think this might be carcinoma that are a part of the stratum spinosum. I don't think that these cells are part of the basal layer. So I'm going to go with 1 for that. Awesome. I mean, I meant to say squamous cell carcinoma. So these and the characteristics, and you're going to go over this with an actual clinician tomorrow, these patches of keratin. And so you'll see that more in depth tomorrow. Another clinical correlation here is that, okay, what we can have other parts of the process of making skin that can be defective. And one of them is that we can have filaggrin mutations. And that can reduce the hydration that the skin cells have. And what you get is a compensatory response. And so you get hyperkeratosis. And so you end up getting this a lot of keratin that is produced in this scaly skin to try to protect the skin and to stay more hydrated. So you get this compensatory response in the body from lack of hydration. You end up having these patches of scaly skin. And that goes along with that. So according to this mechanism of disease in the previous slide, which of the following layers of the epidermis would you think this condition would affect the most? So if we have a lack of hydration and we have hyperkeratinization, which of these layers? And I'm going to go with stratum corneum because that's going to be the layer that has the most keratinized cells. And so that is going to be the layer that's going to build up in a pathologic sense. All right, in this picture, which cellular structure do you think might be malformed, causing this blister? Well, what I see is the dermis interfacing with the epidermis, and the epidermis has fallen off of it, and there's a bunch of fluid in here. So let's see, desmosomes. Desmosomes hold the keratinocytes to each other. So I would imagine this whole thing would break if desmosomes were not, the skin would be very fragile if they were defective. Hemidesmosomes are actually at the interface where the epidermis meets the dermis, so this would be a good candidate. Cilia, no, there's no cilia here. Those apical cellular projections are not really a player in the epidermis, nor are microvilli. So I'm going to go with hemidesmosomes, and that is true. And so That's actually a clinical correlation in this condition called epidermolysis bullosa, where you can get the skin, epidermis part of the skin, separating from the dermis. And what happens is the fluid that's in the dermis, that's in connective tissue, underlying connective tissue, will seep out and fill the space that has come off of the dermis, the epidermis, in the separation. And fluid will fill it, causing blisters. Okay, and then these were team scores that was from before that I didn't get a chance to show you. So if you were in even number breakout rooms, then your teams won, because we went through the first one, but at least you did get to answer. I hope that these answers were helpful for you, and I will see you next time.